All right, so we are in part three here of our lecture on careers in the metals industry and being able to apply the information that we are learning here. One of the other textbook examples here is coming from cooling fins used for automobile radiators. Um, now, of course, the metal, aluminum, or copper foil is kind of bended and shaped into these different fins. The idea here is that, of course, air can blow across those and help to cool the fluids off and cool down the engine as we pump your coolant through the engine block and then through the radiator. Pretty common. Sometimes these are also engineers refer to this sometimes as a heat sink, where we sink actual heat into other parts and then blow air so that it helps as a cooling application. So we had to manufacture these radiators that are doing this and use the radiator fins. Now, um, they realized, that particular manufacturer, that they realized that there's a similarity between the cooling fins on the automobiles and cooling fins that are used for blood coolers and dialysis machines. So of course they were able to capitalize on that just by understanding the nature of that material, already have the machinery and equipment in place to process that, and then they basically were able to take advantage and have a new business opportunity where they could go and not just produce automobile radiators, but also produce this fin stock for the blood coolers that were making those for patients as well. Now, there are different specifications for those as well. So there's problem textbook kind of goes into. There's an order rushed out where they didn't check all the specifications, and of course there's a rejection there. There's gouges and tears in it, which is usually pretty easy to do in thin stock materials. Um, so the technician who made the order apparently wasn't aware of different specifications. So this is where the individual and somebody on the shop floor, so definitely has a responsibility to make sure that you know what design requirements are and are paying attention to differences in this type of material that's being used, and telling and paying attention to any scratches or gouges or anything else that might come into play that cause us a defect in the quality of the work that we're putting out. So um, it also talks here in the chapter, of course, all of us in Illinois who've been up around Chicago have been to Chicago's Cloud Gate, although many of us probably don't know what that material actually was. So, and in the design concept behind it, they were going into several different materials. Of course, the textbook goes into how couldn't use ordinary steel because it rusts. Chrome-plated steel requires some different things and doesn't maintain shine at the weld points. Aluminum, of course, requires frequent repolishing. So the metallurgical solution here, and this is of course from an artist or sculptor's standpoint, using weldable stainless steel and a filler metal that matched in color, then was able to use the arc and laser welding processes to basically give good welds, polish, and ground where it leaves no marks on the surfaces. And there we have the immortalized Chicago bean, otherwise known as Chicago's Cloud Gate, as one of the sculptures that is basically metal being used in stainless steel up in Chicago. So those are some of the areas here where we talk about application of this. Now, in my own experience, work experience too, especially in the canning industry, uh, the company that I worked for made a lot of bottle caps, and of course they had the steel leftover sheet after they were pressing and punching those caps to start them out at. Well, they of course always looking to reduce and recycle. They were left over that, and they thought, well, what could we use it? Well, somebody, one of the engineers, uh, had the foresight to realize that kind of the shape in the sheet metal after the uh, bottle caps are punched out was similar to what the um, filter manufacturers, as far as your furnace filters, were using in there too. So additional business opportunity. The company I worked for, their waste material, that scrap that they were usually thrown away, actually became a sellable product that they could sell into the furnace um, filter manufacturers there that had that need. So, kind of paying attention to some of these different material requirements. Metallurgy and the shapes that are generated also helps to build additional business um, possibilities and solutions to increase sales and do better. So gives you an idea there. So as we conclude this, we know that metals are everywhere. It's kind of hard pressed to look at any type of product that either hasn't came in touch with metal or is metal that we're using of some sort in some way. So if you think about that, just a general knowledge of metallurgy um, can really, really benefit those of us in industrial technology and in manufacturing. So uh, there's a great need for this information. And of course, as things advance, so as materials get more and more complicated, as we uh, learn how to reduce, reuse, and recycle, we have to kind of think about how we can repurpose some of this material. We also need to think about as we use up the existing materials that we can, how we can change materials to still maintain and get strength and continue to make the products that we like to have that make our lives simpler and easier to use. So there is no shortage of demand for people with knowledge of industrial materials. So um, and basically problem solvers to think out of the box. So that's kind of the emphasis that we're going to discuss in this class, is trying to think of all these different ways here and the applications that are going to be used, so that you can think critically when you're out there in the job working and using the machinery, cutting the metal, welding the metal, doing whatever that you need to do to make good products out of the metal as well. So if we're talking about advanced metallurgy, so again, like I said, new innovations, breakthroughs are happening all the time. I think nowadays it's probably a little bit more involved in composites and nanomaterials, but certainly um, traditional metal work is still there, and there's still a big need on that. So just as an example given is oil spreading onto a metal sheet, how that oil can reduce rejected parts, and you may be able to increase your speed when you're in the stamping or forming process. Um, that may result in reduction of production costs. Now, on the other hand, kind of going back to my own experience, I did work at one point on a assembly line type application where they were trying to increase production. It was more or less a automated line that was feeding cans from down in a more or less an assembly line type track through these rollers and conveyors, and it would have to turn at 90 degrees. So these cans would all come into a mandrel arm and then kind of be spun around to 90 degrees to go into different locations. So kind of think like a sprocket that's sending one line, conveyor line, feeding a lot of cans into a centralized spoke, and then that spoke would distribute the cans and going into different directions. Now, the engineering staff at the time decided that if they changed over, there were some mandrel arms that were made out of cast steel at that point, cast iron, and they were very, very heavy. So the decision came about to change that cast iron into aluminum and to make them out of high tensile strength aluminum instead. So, of course, I worked on the project to design the new mandrel arm and the metal and machine it and get our machining processes down. So we made those aluminum mandrel arms. And then they realized, or the idea behind it was that it would speed up this process and make it go so much faster that they would be able to um, move these cans 3 times faster than what they were currently going. And I forget now exactly, but I believe the cans were going into filling stations to be filled with whatever product that they were being filled with. So, and they wanted to speed that production up. So now it was a great idea and a great concept. We changed over from cast iron mandrel arms into these 7075 T6 aluminum, aerospace grade aluminum, to machine these mandrel arms. And they put the whole thing together, started to crank it up. It ran at the same speed that the cast iron ones did. They increased the speed, and they were never able to achieve the higher speeds that they were expected because the aluminum still didn't quite have the strength, and the aluminum mandrel arms cracked and broke in the process. So there are ideas here too that kind of come about. So whether now I was a CNC programmer and a machinist at the time, so you work on some of these projects and you get these ideas, or you kind of need to be familiar with some of this different materials, and you'll run into experiences like that you kind of somebody in the organization has the idea, you try to implement it, and you of course always are hoping for the improvement and the best, but sometimes it doesn't always work that way, and you kind of have to go back to square one. So that's kind of two experiences in my past history of where having a general knowledge of metallurgy has kind of played a role, and one that helped to make an improvement, and another where it didn't quite have the same impact as well. So, and that was a long time ago too. So I'm sure that by now, 20 years later, they definitely are moving that equipment a lot faster than what they were 20 years ago. So as we go through, remember, so the main thing behind this is we take all sorts of different elements and different metals combinations. We put them through a variety of different processes between the composition and the processes that are put on those, whether the processes to actually make the sheet steel or the bar stock or the plate, then the heat treating processes and the annealing processes that are put through. That all changes the microstructure of the material on a microscopic level. Changing those chemical bonds between the alloys. And of course, that gives us different properties that are desirable for whatever we are using that material for. So that's the main takeaway here as we go through. And as we kind of really start to dig deeper into all of the industrial materials that we're going to be looking at over the course of the next 13 weeks in this class.